Hello and welcome to the first Camworks tutorial. To start this tutorial, you will have to open the intro part, which you will have had to copy and save to somewhere where you have write access. You can obtain this part off of the M drive. The first thing it'll prompt you to do when you open this part is it'll ask you if you want to proceed with feature recognition. This is because, as you can see over in the feature tree, there's some imported geometry. Just check "Don't ask me again" and hit no. The next thing we'll have to do is we will have to add Camworks in. To do this, you'll have to go to Tools, just like for power surfacing. Go down to Add-ins, scroll down and select Camworks 2014. Once this activates, you should have two new tabs, as well as a couple new new menus over here. So first of all, let's take a look at these two new tabs. There's Camworks 2014 Workflow, and you can see we can define machine, stock, we'll get into these in a little bit more detail. And then there's also Camworks 2014. Realistically, you can find most of the tools you'll be using in both of these menus, so it's up to you which one you will work with. For this video, we will primarily be working out of the Camworks 2014 menu. Continuing to look around to see what else was added in, we're going to look and notice that there's a couple more tabs available near our feature menu. We can see that there is a Camworks feature tree and a Camworks operation tree. So what I'm going to do is I'm going to select the feature tree, and we're going to take a look inside. Now, with the feature tree, you will see various configurations of your part. Whatever machine we are anticipating working on, in this case it's a mill inch, and a stock manager. Now clicking on the stock manager, you can see that there's this blue highlighted stock that seems to be a cube that bounds the sort of total dimensions of this part that we have here. But before we and that's a stock manager. If we go now to the operations tree, we can see again it looks almost the same as the feature tree. Configurations, a machine, and a stock manager. We'll get into the difference between these two a little later. But for right now, what we're going to do is we're going to do a quick overview of the process that you will have to do every time you generate code to create a part via any CAM computer automated manufacturing system. As you can see, this is the general process. The first thing you do is you model the part. We already have that done. The next thing we have this Camworks feature tree, and we have to define the machine and change controller parameters. You could easily see how unless you know what machine you're using to create a part, it's somewhat difficult to generate operations for a machine you don't know and are not familiar with. After you define a machine, you have to define stock. Again, it's hard to know where to cut if you don't know what you're cutting. After you define the stock, you can define machinable features, and we'll get into what those are a little bit later. To do this, there's sort of two ways. There's AFR and IFR. AFR stands for automatic feature recognition, and IFR stands for interactive feature recognition. Automatic is, well, automatic, and interactive means that you have to pretty much do everything. After you define these machinable features, you have to generate an operation plan, and then adjust the operation plan parameters as needed, generating tool paths, simulating the tool paths, and then evaluating based off of these simulation whether or not they are correct and appropriate. If they are not, you'll simply go back and adjust the operation parameters to whatever needs to be changed, regenerate the toolpaths, and simulate. You'll continue this process until the simulation is correct. You will post-process your code. This will create G&M code, which is standard machining language code, which can be ported to all sorts of computer-controlled machines, such as milling machines, lathes, multi-axis machines, EDMs, and all sorts of automated machinery like that. After you post-process the code, you are done with the computer. You can simply transmit the file via flash drive or floppy disk into the computer-controlled the CNC machine, and the CNC machine can cut your part. So this is a very important process that you need to keep in your head as we go, because it's very easy to forget about some of these initial things. Going back to SolidWorks, we're going to go through this process with this part. Now the first thing we do is we model the part. We've already got that done. We've already changed to the Camworks feature tree. So now the first thing we do is we select our machine. Unfortunately, we don't have any specific machine that we're running this off of. For now, we'll just select mill inch. And you can see that in addition to just this machine, where we have a few different default machines, we have a tool crib tab. This would list possible tools that we'd have for this machine. This will affect how Camworks selects a tool for various features that you define. Thus, not only is in selecting the correct machine, but also selecting the correct tool crib. For us, we will use crib 4 English, and we just click select. Next up is the post processor. You have to make sure that you use the correct post processor for whatever machine you're using. Since we're not going off of a specific machine, we can just simply keep the default, which should be M3 axis tutorial, and just hit select. Next is posting. Again, these are all some specific things. You don't really have to worry about this. Setup. We can include fixture coordinate systems or various indexing things. Again, this is again more advanced features, so we're going to skip over this for now. Whether or not the machine has a rotary axis, in this case we're going to assume it does not, or a tilt axis, again assuming it does not. So the main things right now that you should concern yourself with are making sure your machine is mill inch, your tool crib is crib 4, and your post processor is M3 axes. And we're going to select OK. And that completes that step. So next we have to define stock. So going back to SolidWorks, if we double click on the stock manager, we see it brings up a few different options. We have material. We can change to different types of material. For now, we're going to switch to 6061, which is an aluminum alloy. This is the most common component or most common material that you will probably use in your time at MCC. And then we can look further down. We can see different stock types. We can see a bounding box, which, as you can see by the blue silhouette, this is what we have selected right now. We could also do an extruded sketch or a STL file. We're going to stick with bounding box for now. The next thing you can do is you can do a bounding box offset. As you can see, this blue box is the smallest box possible that will fit our part. If we increase the X, you can see that now we have a little bit of extra space around it, and decreasing it, so forth. And you can increase it in the positive or negative direction, and you can also increase things in the Y and Z axis. For now, the default bounding box will work for us, and as you can see, you can have multiple number of stocks, and it becomes quite complicated. But for now, just make sure that you have a simple bounding box with 0 offsets, and we're going to hit OK. So now we've selected our stock manager. Next up is defining machinable features. For the purposes of this tutorial, we're going to use automatic feature recognition. Interactive feature recognition will be covered in later videos, as it is more complicated and delves more deeply into how the CAM software is running. So to run automatic feature recognition, simply go to the Camworks 2014 toolbar and click Extract Machinable Features. You'll see this message window pop up where it says, these various messages in it, and you've got this progress bar. Depending on your machine, this may take a few seconds to a minute or two to run. And now what you see is you see a lot more stuff in our feature tree. You see this mill part setup 1, and if you click it, you see that there's this centered on this hole. And then you see all these pink features. So before we get into it, I just would like to explain what a mill part setup is. Right now we are assuming that we have a 3-axis milling machine that we are going to create this part on. What a mill part setup for a 3-axis milling machine looks like is it defines the z-axis as going in the direction of this red arrow, and that is the negative z-axis, and we were cutting down into the z-axis. The point of it is also, you can see, represents the 0. The point of that arrow represents the 0 in both the x and the y and the z. If for any reason we needed to change this parameter, we could simply adjust the setup, and we will do so in a later video. Looking at these pink features, we can see an open pocket, a rectangular pocket, a hole, countersunk hole, multi-stepped hole, counterbores. We can see quite a lot, and they're all pink. Now these are all different machinable features. And the pink, the reason they are pink is because these machinable features have no operation plan. So, and what I mean by that is there is no method or plan to machine these machinable features. These are just simply features you could select to create a plan to machine them. So let me, before we go further, let me just show you, we're going to switch to the operation tree. And we see that the operation tree looks like it does before. We have the machine, the stock manager, and the mill part setup. So now we have this mill part setup. This was added when we extracted the machinable features. And what you're going to see is when we generate operation plan, which is the next step, each of these machinable features is going to have a default plan associated with it. For instance, open pocket is going to generate a rough mill where it removes all this most of this material in this sort of green highlighted box, and then a contour operation where it goes around this rectangle, around this irregular shape, and around this slot. And each one of these different machining features have a different operation plan. For instance, a hole may come in with a center drill and then come in with a drill. And those are two different operations for that one machinable feature. So what we're going to do next is we're going to generate the operation plan, and we're going to look at some of the operations and how they tie to the machinable features. So we're going to click Generate Operation Plan. Again, the message window pops up, and again, this takes some time, depending on your computer, anywhere from a few seconds to a few minutes. And now we can see we've automatically switched to the operation tree, and we've got it quite long. And again, they're coming purple. But for now, what we're going to do is we're going to switch to the Camworks feature tree. We're going to look back at that. And now you can see that except for this one rectangular pocket, which we'll look at a little bit more closely later, all of these have turned black. What this means is all of these now have an associated operation in order to create these. So what we can do is we can go into the operation tree and we're going to start looking at these operations. And this is a somewhat complicated part, so this may be difficult to see, but subsequent videos will be dealing with less busy parts, and it'll be a lot easier to see what specifically is a machinable feature and what is an operation. So for now, don't get too worried if you're lost. This is mainly just done to show you how powerful and easy to use Camworks can be. So we see that there's a center drilling operation right here and a drilling operation right there, all centered on this same machinable feature. And again, the machinable feature comes in green. So for any of these operations, I can see which machinable feature came up based on what came up in green. So this rough mill comes up in as this shape in green. Looking over here, I can see that open pocket 1 comes in the same machine, the same shape. A regular pocket down here, that's its own special shape. And if we go down to this contour mill, we can see this contour mill and this rough mill are both off of that irregular pocket. They should come up somewhat in order, but every now and then Camworks does a little bit of a little bit of switching around on you, so it can be annoying, especially on a part as complicated as this, to tie every single operation to its associated feature. The next step in our cycle is adjust operation parameters as needed. Each of these operations comes with operation parameters. One of the most important operation parameters is tool. What tool does each operation use? And you can see that this rough mill is using tool 12 out of our tool crib, which is a 1.5-inch flat end mill. This contour operation is tool 13, and it uses a 2-inch flat end mill. And we can see that each of these operations has an associated tool. Some of them even use multiple tools at the same time. As you can see, this rough mill and this contour mill use the same tool, tool 27. And this rough mill and this contour mill also use tool 27. It's important to note that any operation parameter can be easily changed by simply editing the definition of the operation. We're not going to get into those menus today because those can get quite complicated. As you can imagine, operation parameters can range anywhere from tool to tool holder to feed rate and speed ratings to cutting parameters such as depth of cut and ramping in and ramping out, all sorts of things which many of you won't be familiar with and many of you don't even need to know. But again, we will go into those more detailed in later videos. For now, what we're going to do is we're just going to assume that the default operations parameters are appropriate enough. So we're going to do the next step in our cycle, which is generate toolpaths. We're going to do this by clicking generate toolpath. Again, that process could go quickly or slowly. And now you can see that we've got some more lines on the screen. It's making it a little bit more difficult to see exactly what we have. So if you select any of these operations, you'll see a few lines come up. And these can be lines of dotted red lines or blue lines. What this means is this is showing the tool path that the tool is planning on taking. The red line shows where the bottom of the tool is. It drops down. Red line typically indicates at a rapid speed, and then it starts at this blue line to go at whatever feed rate you have selected, and again as an operation parameter. Then you can see it goes around and around and around, and then it comes up and goes over. And all of these different operations have different tool paths. Next step in the tree is to simulate these tool paths to get an idea of how well this part is being cut out. So we're going to go to Simulate Tool Path. We're going to hit Run. And you can see the tools dropping down. And this is going pretty quickly. So what we're going to do is we're going to slow it down a little bit just by toggling this line. Now we can see maybe a little bit more realistic speed. And we can see the shapes that these tools are using. But ultimately, we have a complicated part here. It's going to take some time to run, so we're just going to speed it up. Okay. So, to me, this doesn't exactly look correct. So what we're going to do is we're just going to see how far away it is by clicking this Show Difference button. And we can see that we have quite a lot of, all these blue areas are areas where we have extra material. So we have this whole feature that was not selected. We've got this space in between these contours that wasn't correctly machined. We've got a lot of work to do. But again, it's an iterative process. If you go back to this flowchart, are the tool paths correct? In this case, no, they are not. Now, based off of this simulation, which I'm just going to run quickly again, we can infer that there are some things that, and I'm going to restart it in case you missed it. We can see that there is some problems. One of the problems we can easily see is this first tool. If we speed this up a little bit, we can see that this tool is too large to correctly cut out the feature it's trying to cut out, namely being those islands. It's too large to fit in between them, thus it leaves material in between them and doesn't correctly machine the feature. We can change this by simply selecting this rough mill and selecting a smaller tool. To do this, what we will do is we will simply go into this, edit the definition, and we will go Tool, Mill Tool, Tool Crib, and we'll scroll down, and we will select a smaller end mill. Let's say this 9/16 end mill or other small diameter end mill. Click Select. We will change the corresponding holder and hit OK. Now that we've changed this tool, we can see that these tool paths have updated to be quite a lot longer. This is both good and bad. You can see now we are getting the fine detail in between these features, but as you can imagine, this process would take quite a bit longer. So we're going to simulate now again by pressing play. And we can see now our part looks quite a lot better. We still have one missing feature, but that's something that we can work on at a later date. This concludes the introduction to Camworks. The next few videos will cover how to perform basic operations in detail, such as pockets, bosses, holes, and face features. Thank you for watching.